हेलो स्टूडेंट्स। आज हम एक टॉपिक डिस्कस करने वाले हैं, दैट इज़ सिग्नल। हम आज देखने वाले हैं सिग्नल क्या होता है और कितने टाइप्स के सिग्नल्स होते हैं, क्लासिफिकेशन सिग्नल के कौन कौन से होते हैं। तो सिग्नल क्या होता है, बेसिकली इट इज़ द फंक्शन ऑफ टेम्परेचर, पोजीशन, डिस्टेंस, ईटीसी। तो क्या होता है सिग्नल? सिग्नल एक इंडिपेंडेंट वेरिएबल का एक फंक्शन होता है। इंडिपेंडेंट वेरिएबल का एक फंक्शन जिसमें कुछ इन्फॉर्मेशन होती है, जो कि क्या करता है, कुछ इन्फॉर्मेशन को कंटेन करता है। तो बेसिक डिफरेंट डेफिनेशन की अगर बात करें तो डेफिनेशन क्या होती है? सिग्नल कैन बी डिफाइंड एज अ फंक्शन ऑफ one or more independent variable which contains some information, that is signal. So what is the signal? The signal may be defined as the function of one or more independent variables which contains some information known as signal. सिग्नल के एग्जांपल्स की अगर बात करें तो डेली लाइफ में कौन कौन से सिग्नल्स हमारे यूज़ होते हैं, लाइक स्पीच, म्यूजिक, वीडियो, पिक्चर, etc. These are the common signals which are used in our daily life. Okay. Next we will discuss about the classification of the signals. कितने टाइप के classifications होते हैं सिग्नल के? तो first one is continuous time signal. And another one is discrete time signal. दो बेसिक टाइप्स यहाँ पर होते हैं सिग्नल के, दैट इज कंटिन्यूस टाइम सिग्नल एंड डिस्क्रीट टाइम सिग्नल. दैट these two types of signals, classification of signals, are further classified into the more types we will discuss in the next. First we will discuss about the continuous time signal. Okay, what is continuous time signal? The continuous time signal is that which have some value at every instant of time, like this is the one signal, any signal, that is the function of time, x of t. Like x of t is any signal which is continuous. We can see it is continuous at every instant of time. It has some amplitude, it has some value at every instant of time, 1 2 3. We can say that at 1.5 it has some value, at 2.5 it has some value. So it has, the signal has continuous in nature. So what it says, the continuous time signal is defined as a signal which contains or which has some value at every instant of time, that is continuous time signal. And another one, we will discuss the discrete time signal. What it is? It is defined as, it is also defined as, the discrete time signal is one which has amplitude or which has some values at a particular instant of time, like this. So it is not continuous in nature. It has some value at particular instant of time, like 1, 2, 3, 4, -1, -2. Okay, it has some value at particular instant of time, so that's why it is called discrete time signal. The continuous time signal and discrete time signals may be further classified under some categories we will discuss about. These two signals are further classified as deterministic and non-deterministic signal. Second, periodic and non-periodic or aperiodic signal. Third one is even and odd signal. Even and odd signal. And fourth one is energy and power signal. So these are the classification of the signal, these four basic categories of signals which we will discuss about. Okay, the first which we will discuss the signal, that is deterministic and non-deterministic signal. What is the deterministic signal and what is the non-deterministic signal? The deterministic signal is that which can be completely specified in time, जिसको मतलब अगर हम बात करें सिग्नल की, तो डिटर्मिनिस्टिक सिग्नल वो सिग्नल है जो कि कंप्लीटली टाइम में स्पेसिफाइड होता है एंड द पैटर्न ऑफ दिस सिग्नल विल बी रेगुलर. मीन्स लाइक साइन वेव की अगर हम बात कर लें, दैट इज गिवन बाय लाइक दिस. So it is the regular pattern signal. It is the regular pattern signal. So this is the deterministic signal. Okay, the mathematically we can characterize this signal, that is known as the deterministic signal. The mathematical expression of this signal is x of t is equals to a sine omega t. Amplitude is a, so it is also written as a sine 2 pi f t. 2 pi f what? Omega is equals to 2 pi f. This is the frequency. On the other hand, the non-deterministic signals are those signals which has not or which is not a regular pattern, like this. The non-deterministic signals are also known as random signal, that are random in nature. So we cannot mathematically determine this signal, the what it is exactly, what is the value of the signal at any time. We cannot find the value of this signal at every instant of time, and we cannot specify this signal in the in mathematically and mathematical expression. So this is known as the non-deterministic signal or random signal. Okay, the next point is periodic and non-periodic or aperiodic signal. So what is the periodic signal and what is the non-periodic signal? The periodic signal is one which repeats itself after a fixed time period. That means after a fixed time period it will repeat itself. We can see the diagram like sine wave. After a fixed time period, that is pi, after a fixed time period it will repeat itself. The time period is t. Okay, after the time period t, the signal will repeat itself. That's why it is the periodic signal. It is the sine wave. The function is a sine omega t. So it is known as periodic signal. The condition for the periodicity is given by x of t is equals to x of t plus capital T 0. It is the condition for periodicity for any signal, where t0 is known as period of any signal x of t. It is the period after which the signal will repeat itself. And the non-periodic signal or aperiodic signal is one which does not repeat itself at all. It is known as non-periodic or aperiodic signal. The example of the aperiodic signal is exponential signal, like this. X of t is equals to e to the power minus alpha t. It is the exponential signal. It does not repeat itself at all. Okay. The condition for non-periodic signal is also given by x of t is not equals to x of t plus t0. It is the condition for non-periodic signal. Okay, the next classification is even, symmetrical or odd antisymmetrical signal. The even signal or a symmetrical signal is one which satisfies the following condition, like x of t is equals to x of minus of t, where x of t is the value at t is equals to positive, and x of minus t is the value at t is equals to negative. So the signal will be even if it satisfies the condition x of t is equals to x of minus t. The simple example or the best example of the even signal is cosine wave. Cosine wave or cosine function, like from the figure it is clear that it is the mirrored image of the signal. We can see the diagram. If we fold the signal, then we can get the signal folded signal or a mirrored image of this signal. Though it is the cosine wave, it represents the even or symmetrical signal. Or on the other hand, the antisymmetrical signal is different from the even signal. The antisymmetry signal is that which satisfies the condition of antisymmetry, that is x of t is equals to minus of x of minus t. This is the condition for antisymmetry. The best example of the antisymmetry signal is sine wave. Odd signal. Sine wave is odd signal. By the diagram we can see so it is the example of antisymmetrical signal. From the diagram we can see that we cannot get the mirrored image of this signal. Whenever we follow this signal, we cannot get the mirrored image. So that is the uh, odd signal, or we can say antisymmetrical signal. The next one is energy and power signal. What is the energy signal and what is the power signal? The energy signal is one which has finite energy and zero average power. Okay. Though, so what is the energy signal? The energy signal is one which has finite energy, that is E is less than infinite or greater than 0. E is less than infinite or greater than 0, and finite energy and zero average power, that is P is equals to 0. So it is the condition for energy signal. Okay. On the other hand, the power signal is one which has finite power and infinite energy, that is P is less than infinite and greater than 0, and energy is infinite. So this is the condition for power signal, where E represents energy and P stands for power. So these are the basic classification of the signal. In the next class, we will discuss about some numerical problems based on this classification of signal, like energy and power, even and odd signals, periodic and non-periodic signals. So this is the classification of signal. Okay, in the first we have discussed the continuous and discrete time signal, so which we will discuss some uh, continuous and discrete time signal, like x of t is stand for continuous time, and x of n for discrete time. So t stands for continuous time and n stands for discrete time. Okay, thank you guys. Next class we will discuss about some numericals based on the classification of signals. Thank you.